Hi all, I am Dr. V. Pungoday. Today's topic is second unit vector calculus. First I will say what are all the topics to be covered in the second unit. So it's nothing but gradient, divergent, curl, sinusoidal, irrotational, directional derivative, angle between. So these are the small topics to be covered, which is the basic of your vector calculus. And second topic is nothing but line integral, surface integral and volume integral. This we have studied in the first unit itself. So line separate, surface separate and volume. So it's line nothing but single integration, surface is double integration, volume is nothing but triple integration. So continuation of that integration. So third topic is nothing but Stokes theorem. Fourth is Green's theorem and fifth is Gauss divergent theorem. Gauss divergent theorem is particularly only for a cube and parallelepiped. So the Stokes, Green's and Gauss divergent the theorem proof no need, only the statement plus problem. Statement with the formula and problem oriented will be the big question. So in this video, so only the formula related to the second unit, it has been discussed. For example, what do you mean by del? Del is nothing but we have to write the del like this, upside down. Okay, del, this is called del. We have to pronounce it is operation. So it is nothing but del. So when I tell del means you have to write upside down. The triangle upside down when I write it's called as a del. It's nothing but I vector into dou by dou x plus j vector into dou by dou y and k vector into dou by dou z. Okay. So vector everyone knows it's nothing but I vector with respect to the x axis and j vector with respect to y axis and k vector with respect to z axis. Okay. X, y and z. I vector we will denote it and j vector and k vector. K vector always the direction, the symbol like this, where it goes. So the denotation is called as the vector. So gradient means del, this del into f vector dot product when I use it's called as a gradient. Divergent is nothing but div, first three letters only, div of dot v vector. Here no vector. Gradient means no vector. F vector is no vector. Here vector is called as a div dot product only, but it is a vector. So it is div is nothing but del only. So del dot v vector. V vector, for example, if it is v1 into I vector plus v2 into j vector and v3 into k vector. So depending upon the question, it will change on. So next is curl f. Curl is nothing but del cross. We will use the name to be curl. So del cross f vector. How we have to write? Write it in the determinant format. I vector, j vector and k vector. The second row dou by dou x and dou by dou y and dou by dou z and f1, f2 and f3. So when I write it in a determinant format, so all this determine you get one answer, that is the curl of f vector. Sinusoidal means, so how to check a sinusoidal is nothing but div of f vector. When we get the answer to be 0, it's called as a sinusoidal vector. So irrotational vector del cross f vector equal to irrotational. When we find the curl of f, so answer when we get a 0, it's called a irrotational. Directional derivative del f we have to find it into a cap. A cap is nothing but a vector divided by modulus of a vector. A vector will be given in the question. So it is directional derivative. Same way, unit normal vector is nothing but n cap. Normal vector we denote it as n cap. Phi will be given in the question, del phi divided by determinant of del phi. When we calculate, it is a unit normal vector. Angle between two surface will be given in the question. The phi 1 and phi 2 will be given in the question. So when two surface has been given, the angle we can calculate is nothing but cos theta is nothing but del phi 1 into del phi 2 dot product divided by determinant of del phi 1 into determinant of del phi 2. Line integral, everyone know line integral is nothing but single integration. So f into dr. Dr is general, dx into I vector, dy into j vector plus dz into k vector. because how it comes means r vector. R vector, what it is? R vector x into I vector plus y into j vector plus z into this is z into k vector. So that you differentiate. Dr is nothing but dx into I vector plus dy into j vector plus dz into k vector. So this is the way. When you get the single integration 0, then we can say the field is conservative. It's nothing but del cross f is 0. Okay. So we can special case it. This is a special case. When particularly any problem we are getting 0 means we can say this is special case to be it's a consecutive. The field is to be consecutive. So surface integral, it's double integral over f vector into n cap into ds. N cap is nothing but del f divided by determinant of del f. ds is nothing but dx into dy divided by n cap into k vector or k. Okay. Volume integration, triple integral over f into dv. dv is nothing but dz, dy and dx. So these three theorems are very important. The statement you have to learn. So with the formula, the statement Green's theorem is nothing but if two parameter, that is m and n, m of x comma y and n of x comma y be a continuous function of x and y having a continuous partial derivative, when they have a partial derivative, dou m with respect to y and dou n with respect to x in the region R of xy plane bounded by the closed curve C, then we can write the Green's theorem is nothing but single integration over m dx plus n dy equal to double integration over dou n by dou x minus dou m by dou y into dx dy, where C is the anti-clockwise direction. We have to follow with the anti-clockwise direction. Once read the statement, formula compulsorily you have to learn it. The Stokes theorem, the statement, proof no need. If S be an open surface bounded by the closed curve C and F vector to be F1 into I vector plus F2 into J vector and F3 into K vector be any vector function having a continuous first order derivative, then we can write the Stokes theorem. Single integral over F into dr is nothing but double integration over curl. Don't forget it is a curl. Curl into f vector into n vector into ds, where n vector is a unit normal vector at a point of S drawn in the sense in which the right bounded screw would advance when rotated in a sense of description of the C. Okay, how it is rotated, how it is given in the question. When I explain it in the problem in my later video, you can check it. How when I teach in the Stokes theorem, you can verify in that video how it comes. Okay, I will explain it. So Gauss divergent theorem. If f is a vector point function having a continuous first order derivative in region V bounded by the closed surface S, then we can write Gauss divergent is nothing but triple integration over del. Okay, don't forget del. Del into f into dv equal to double integration over the same as Stokes. Right hand side the same, but curl is not there. Okay, f into n vector into ds, where n vector is outward drawn unit normal vector to the surface. So these three are important big problem we will be seeing in the later of my videos in the topic Stokes and Green's theorem and Gauss divergence theorem. Thank you.